Hello everyone! Today we'll be talking about square root transformations. But before we can talk about transformations, we need to go over what the start graph is before your square root function starts moving around. So remember, transformations cause a graph to move away from something called the parent function or the start function. Okay, so every single function we deal with will have a different parent function. So we've talked about this with quadratics. So the parent function for a quadratic will be much different than the parent function for a square root graph. So in class, you guys graphed the square root function. You guys had to complete the table of values, graph it, and find the domain and range. Which when you did that, you graphed this lovely looking square root function. It kind of looks like half of a parabola, and it's kind of facing sideways, like that. So with the square root function, one thing to keep in mind, when you guys are graphing the parent function, I had you guys graph a negative x value on purpose. What happens when you have a negative number underneath the square root? It's imaginary. Okay, so any negative number that you put under the square root will make your value an imaginary number, which you cannot see on a coordinate grid. This is a real number system coordinate grid. So you can only see real numbers graphed on this coordinate grid. So you cannot graph any negative x values when you have a square root function. Okay, so this point right here is where the graph will start. It doesn't keep going. It starts right here. Okay, so it's going to have a start point, and then it's going to extend to the right for forever in one direction. And it does gradually get higher and higher, even though it doesn't look like it. Okay, so then you guys also found the domain and range, which for the domain, you ask yourself, how far left does the graph go? Oh, whoops, I hit the left arrow key, sorry. How far left does the graph go? And how far right does the graph go? So if you look here, when you ask yourself how far left does this graph go on the x-axis, well, this is where the graph starts. Okay, so the furthest left on the x-axis that it goes is to 0. And then when you ask yourself how far right does the graph go, well, this arrow means it's going to continue to infinity and beyond to the right for forever. Okay, so this graph will keep going for forever to the right. Okay, so these values, are they larger or smaller than 0? Well, they are larger than 0, and the graph will also equal 0. If you see, there's a point at 0, 0. So it equals 0 on the x-axis. So your domain would be x is everything that's equal to 0 and larger than 0. And then for the range, you always ask yourself, how low does the graph go and how high does the graph go? So if you see here, the lowest y value, since this is our start point, the lowest y value on the graph is 0. If you see here, the lowest y on our table is 0. Okay, and then I know it doesn't look like it, but the graph does gradually increase and get higher and higher and higher. So when you ask yourself how high does the graph go, the graph will continually get higher and it will go to infinity and beyond with Buzz Lightyear. If you didn't know, Buzz Lightyear hangs out at infinity, which is really cool. So it will keep going up for forever, which means the values of y will continue to increase to infinity. So are the values up here larger or smaller than 0? Well, they are in fact larger than 0. So your range would be everything that is equal to 0. If you see on your table, there is a value at 0, and then it's everything larger than 0. So it'd be y is greater than or equal to 0. Cool beans. Okay, let's keep going. So with any function, the transformations are always going to be the same. So we talked about the a, h, and k value when we talked about quadratic functions. So guess what, you guys? The a, h, and k will perform the same movements on the graph with the square root function. Pretty neat, I know. Okay, so for the a value, just like with quadratics, when a is negative or less than 0, okay, your graph will flip upside down or reflect over the x-axis. When a is larger than 1 or not a fraction, just be careful, you can't have fractions larger than 1, but typically if you don't see a fraction or if your number is larger than 1, your graph is going to stretch out vertically. I usually imagine like a rubber band. If you take a rubber band and stretch it vertically, it kind of gets more narrow and stretches upward. So your square root function will stretch away from the x-axis, which will kind of make it stretch in an upward motion. Okay, and then when a is less than 1 and greater than 0, so when it's a fraction essentially, that is when the graph will vertically compress. So the graph will get closer to the x-axis, which will make the graph flatten out. Okay? And the a value is also the number right in front of the square root and right after the equal sign. Now the h value is the number that is added or subtracted to the x inside the square root. And don't forget, you have to think the opposite with the h value. Okay, so if it's x minus h, I know that you're tempted to say it goes to the left because we're going negative, but it actually will go to the right. Okay, so if it's x minus h, we go to the right. If it's x plus h, we go to the left. And then finally, the k value, that is the number that is added onto the very end. It's after the square root. And for the k value, you don't think the opposite. So if it's a plus k, you go up. If it's a minus k, you go down. So k value, think kangaroos. Kangaroos go up and down. Okay, the h value, think about horizontal. Horizontal goes left and right. Okay, so for our first 3 example problems, we're going to be just identifying the transformation. So you guys are going to be like math magicians. You're already going to know what the graph does without graphing it. Holy hot dog, right? I know. So let's figure out what the graph is going to do based on the equation. So in example 1, we have this plus 2 on the end. So this plus 2 is after the square root. Is this an a, h, or k value? That would be a k value. And when it's a positive k value, that is when you will go up. So your graph is going to move up 2 spaces. So the answer to example 1, this is a k value, and that plus 2 will make your parent function move up 2 spaces. All right, example 2, this negative 1/2 out in front. Is this bad boy an a, h, or k? Well, the a value is the number that's right out in front of the square root, so guess what? It's an a value. And since this number is negative, typically if you have a negative a value, it will do 2 things. Okay, if you have a negative 1, it will only do 1 thing, but if you have any other negative with another number other than 1, it will actually do 2 things, which the more transformations, the better, right? Alright, so since it's a negative a value, when a is negative, that is when the graph will flip upside down and reflect over the x-axis. And since this one is a fraction or less than 1, this graph will also compress. So it's going to be half the size vertically that it was originally, which is pretty neat. So this transformation is an a value. It will not only reflect over the x-axis, but it will also vertically compress by a factor of 1/2. So that is the transformation that's going on in example 2. And lastly, example 3. This minus 1, we have to ask yourself, is this an a, h, or k? Which this number is added or subtracted to the x underneath the square root. So which value is added or subtracted to the x underneath the square root? Well, that would be an h. You guys are brilliant. Okay, so that is an h value. Now don't forget, h value, you think horizontal, so left and right, but you have to think the opposite with the h value. So if it's x minus 1, we're actually going to go to the right 1 unit. So the final transformation in example 3 is that it is an h value, which will make the graph move to the right 1 space. Well, there you go with example 1, 2, and 3. In a little bit, we'll be talking about example 4 through 7, where we will be reversing this process. So in example 1 through 3, I gave you an equation and you had to identify the transformations. In examples 4, 5, and 6, and 7, in 4, 5, 6, and 7, you guys will be given transformations and you have to make your own equation based off of the transformations. So that's going to be exciting. So get pumped up for examples 4 through 7.